Okay, here's one to introduce a strip footing to you and the concept of a factor of safety. So the information we're provided, it's a strip footing. It's got carrying 800 kilonewtons per metre run of footing. Depth is 0.7 of a metre. We're in a gravelly sand. C effective 0 and phi effective is 40 degrees. So what we've got to do is work out the width of the footing to give us a factor of safety of 3 against a bearing capacity failure. Don't get too worried about the load being 800 kilonewtons per metre. We'll just work in 1 metre strips of the footing. So it's really just 800 kilonewtons we're going to calculate with. Gamma above the water table is 17 kilonewtons per cubic metre, and gamma sat at the water table and below is 20 kilonewtons per cubic metre, and the water table is right at the foundation level, 0.7 metres below the surface. I'll even give you N gamma for 40 degrees is 95, and NQ is 64. There's no need for NC because cohesion is 0. They're the only two we need. So we're going to calculate first the gross ultimate bearing capacity, which is just QU, it's actually QF, but don't worry too much about it, equals a half gamma prime B and gamma plus gamma D and Q. Remember I said do them in the order of strip, square and circular footings, go 0.5, 0.4, 0.3. Because we're on a strip, this factor at the start is 0.5 or a half. Okay, so going on from that equals 0.5 times 10.2 effective gamma times B, which is the unknown, times N gamma, which is 95, plus 17 times 0.7 depth times 64. So what have we got in this? We've got 17 is the gamma above the blade of the footing, and we've got 10.2, which is the gamma saturated below the bottom of the footing. This whole third section is that resistance to uplift force, and this one is the downwards lateral stress. But anyway, just work that out. It solves down to 485B. What are we? Plus 762. So we've got a solution for the strength at the ultimate bearing capacity strength at the underside of the footing. Okay, so we need to work out the net strength at foundation level. What we worked out before was just the strength at underside of footing. We need to remove that overburden stress for the material that was excavated, and that equals QF minus the overburden pressure gamma D, which equals QF minus 17 by 0.7, which equals 485B plus 750. So now that's the net strength at the underside of the footing. So what do we need to calculate now? We know the strength of the underside of the footing. We need to know what the load is going to be on it. So the foundation pressure, Q equals 800, the load, divided by the width of the footing, minus 17 by 0.7 for removal of the overburden pressure. So therefore, if the factor of safety was 1, let me write it out, 485B plus 750 equals 800 on B minus 12. So that equation is saying that the strength of the soil, the part on the left, equals the load. We want a factor of safety of 3. So what we do is divide the strength of the soil by 3 to give us that factor of safety. And we can solve that down. I'll let you do it. It's simple algebra. B becomes 1.55 metres. So that's the width of the footing to give us a factor of safety of 3. And that's the answer to the question.